Hi guys, it's lesson 4.2 and this is video 1. Today we're going to look at rate of change from two ordered pairs. So our learning target for today is to find and interpret the rate of change from linear, exponential, and quadratic functions. So if you can look at the vocabulary up here, we're going to use some words like average rate of change. We're going to be using coefficient, which we've already talked about in the past as being the number in front of the variable, constant rate of change, and slope. Those are some vocabulary words that we're going to be focusing in on today. So as you see, when we first start with our notes, is the average rate of change or the slope of a ratio is describes how one quantity changes as another quantity changes. In algebra, we're typically comparing the output changes to the input changes. So outputs are our y values. So down here you can see it's the difference in our y's, y2 minus y1, over x2 minus x1. We normally use the variable m to describe slope. So slope is positive. Slope is positive. Then we know that the rate of change is increasing over time. If the rate of change is negative, then it decreases over time. So a positive rate of change means the rate of change is going up, it's increasing, the graph is increasing. If it's a negative rate of change, that means the graph is decreasing or the change is going down. So let's look at a couple of these, how we would actually find rate of change if we were just given 2 points. If we look at the one that we have here, the ordered pair, we want to find the slope. Slope is just another way of saying rate of change right here. So if we wanted to find the slope that goes through of the line that goes through these 2 points, then we take and we use our slope formula. The rate of change, y2 minus y1 over x2 over x1 minus x1. Now this is often called rise because your y's go up and down, and your run, that's your x's go left and right. So we often say rise over run, how much the y's change over how much the x's change. Remember, in your ordered pair, the x's are the first ones and the y's are the second one. If you want to call it, this is your first one and this is your second y, and this is your second x, and this is your second y. Those are all options that you can actually go in and write those in if that helps you. So we're going to do y2 minus y1. So when we look at this, this would be 4 minus 2 over negative 6 minus a negative 4. Don't forget, where people mess up in this is they forget if you got minus a negative, it would make it plus a positive. So we would have a positive 2 over a negative 2, which would be equal to a negative 1. So the rate of change, or the slope, would be negative 1. It would go down 1 and over 1. And that means that it would be going downhill when we graphed it. Over here, you'll do the same. Let's look at this one. It's got, this is your first x, your first y, your second x, second x, and your second y. So 2 minus 5 over 3 minus 3. Okay, so 2 minus 5 is a negative 3. What is 3 over 3? 3 over 3 is 0. So this is not a zero slope. This is where you have a 0 on the denominator. You can't do that. You can't divide by 0. So this is said to have an undefined slope. Okay, and if you go back and review the slope man right here, you can remember that if it has an undefined slope, then it's a vertical line. And you can see that it is because the x values are the same here. That means that it's a vertical line. So now here are 2 u-tries for you guys. Remember, you can refer to slope guy over here. So if you get 0 on the numerator, then that's a horizontal line, so it's a zero slope. If it's going uphill, it's a positive. If it's going downhill, it's a negative. And I will pause while you guys work on that.